This paper is a survey of B-tree locking techniques. It's a 2010 paper. B-trees are by far the most important access path structure in database and file systems. This paper discusses multiple locking concepts and techniques like phantom protection, predicate locks, precision locks, key value locking, key range locking, multi-granularity locking, hierarchical locking, and intention locks. There are two forms of B-tree locking. First is concurrency control among concurrent database transactions, querying or modifying database contents and its representation in B-tree indexes. Second is concurrency control among concurrent threads modifying the B-tree data structure in memory, including in particular images of disk-based B-tree nodes in the buffer pool. These two purposes are usually accomplished by two different mechanisms, that is locks and latches. Locks separate transactions using read and write locks on pages, on B-tree keys, or even on gaps between keys. Latches separate threads accessing B-tree pages cached in the buffer pool, the buffer pool's management tables, and all other in-memory data structures shared among multiple threads. The difference between locks and latches is presented in the table. There are quite a few contributions of this paper. First is concurrency control for B-tree indexes in databases can be separated into two levels: concurrent threads accessing in-memory data structures and concurrent transactions accessing database contents. These two levels are implemented with latches and locks. Latches support a limited set of modes such as shared and exclusive. They do not provide advanced services such as deadlock detection or escalation, and they can often be embedded in the data structures they protect. Therefore, their acquisition and release can be very fast, which is important as they implement short critical sections in the database system code. Moving on, locks support many more modes than latches and provide multiple advanced services. Management of locks is separate from protected information, for example, keys and gaps between keys in the leaf page of a B-tree index. The hash table in the lock manager is in fact protected itself by latches such that threads can inspect or modify the lock table as appropriate. The principal technique for concurrency control among transactions accessing B-tree contents is key range locking. The most recent design permits separate locks on individual key values and on the gaps between key values. Applies strict multi-granularity locking to each pair of a key and a neighboring gap. Reduces lock manager invocations by using additional lock modes that can be derived automatically. Enables increment locks in grouped summary views and exploit ghost records not only for deletions but also for insertions. Now let's give this paper a PS score. It's an easy and engaging read, so on readability it gets 9 out of 10. It's 26 pages long, so on length it gets 7 out of 10. It'll be challenging to reproduce, so it gets 8 out of 10. The industry value is high, so it gets 9 out of 10. There are a lot of interesting observations and findings in this paper, so it gets 10 out of 10 on Learning Meter. So the overall PS score is 9 out of 10.